In this video, let us have a look at collections framework in Java. So we will see what are the different types of collections and most importantly, when to use those collections. As you can see on the screen, these are the main types of collections: list, set, queue, DQ, and map. Now let us see when to use each of these. Most frequently collection is the list, and you can use the list collection to store all types of items. So just imagine that you have got a lot of products that you want to store, so you can put it in the list. Simple. But then why you want to use the set then? Because in the list you can store the products, and in the set as well you can store the products. Then why to use the set? So main difference between the list and set is that in the list you can have the duplicate elements, okay, or items. But in the set you can store only unique elements. So that is the main difference between list and set. So based on your requirement, you can go for one of these. But if the items that you want to store in the collection is less, let's say less than 100, then you don't need to even go to the set or queue or DQ or map. Okay. If the number of elements that you want to store in the collection is less than 100, then you can use the list and still you can have the features provided by the set, queue, DQ, and map. For example, in the set, it allows only unique products. But if you're using the list and you want to add this condition, what you can do is that before adding the item in the list, you can check if that item already exists in the list or not. If it doesn't exist, then only add that item. Or if the item already exists, do not add the item. So that way you can still use the list and have that unique products or unique items in the list. So you don't need to use the set. Then why we have the set in the first place? Because with the list itself, you can have the unique elements as well in the list. The main reason why we want to use the set is because of the performance. So, every time you want to add the item in the list, you will need to search for that item before you can add it. And that searching is provided by this contains method, which has the time complexity of O of n. What it means is that if the number of elements that you want to store is high, the time needed to search that element in that list is going to be higher. But with the set, it's pretty much faster. Okay. So on average, the time complexity is O of 1. That means you can quickly find if the element exists in that set or not. And that's the main reason why we want to go for the set performance. But as I said earlier, if the items that you want to store is less than 100 or it's a small number of items that you want to store, you can definitely go ahead with the list only. The same thing applies to the queue as well. So in the queue, what happens is that items can be added from the rear and removed from the front. So basically it follows this FIFO style, first in, first out. And you don't need to use the queue for this. You can still use the list and implement these features within the list if the sample size or the item size is smaller. So what you can do is that we can have the list and then let's say you want to add the item. So when you add the item in the list, it is already added in the end. Okay. And in the queue as well, we add the item in the end. So that is sorted. It is much faster. The problem comes when you want to remove the item. So in the queue, what happens is that it always removes from the beginning. And in the list, what you will have to do is that you will have to remove the first item from the list. So remove 0. So with that, what happens is that when you remove the item from the list, you will have to shift all other items if you are using the array list. So that way it becomes very time consuming, and that's why we have to use queue. So again, for the performance wise, you have to use the queue, but if the item size is small, then you can still use the list and implement these features. The next one is double-ended queue. So with the double-ended queue, what happens is that you can add and remove the items from the front end of the queue as well as rear end of the. Again, you can use the list, implement the double-ended queue features in the list, but again for the performance, reasons we use the double-ended queues. Finally, we have the map. So the map, what happens is that we store the key value pairs. So there is a key and then corresponding to that key, there is a value. It can be any object. Again, what basically we are doing is that we are storing some data in the collection. And as I said, we can still use the list over here as well. Only difference is that there will not be any key. So key will be part of the object that we are storing in that list itself. And if you want to say get the item where say key is XYZ, what you will have to do is that you will have to first search that item in that list and then check if that key matches. Okay. So you want to find the product details for the given product ID, then you will have to search for all the products and then find the product where the product ID is say XYZ. And once we find that particular item, you can just return that object. Simple. So again, if your sample size is very small, don't need any of these collections. Set, queue, double-ended queue, map is not required at all. But if the sample size is huge, there's lots of items, thousands of items you want to work with, then at this in that instances you will have to look for these other alternative collections where the performance may be higher depending upon your situation.